An integration problem has popped up this past week that looks as if it's of moderate difficulty, and so let's give it a try. So we're going to write the integral symbol down, and it's an indefinite integral, and the integrand is a rational expression. So in the numerator it's x squared plus x, and in the denominator it is the square root of x plus 1, and then dx. And we want to make an attempt of integrating this. And so what might occur to you first? Well, you might be taking a look at that numerator and thinking anytime you see something like that, you can certainly factor that. So let's do that. Let's factor that. We'd like to simplify what we've got here. If we can simplify the integrand, it might help us out. So go ahead and factor out the x in the numerator, and so we have x times x plus 1. And then in the denominator, instead of having a radical, what's another way we could write that? Well, we could write that as x plus 1 to the 1/2 power. That means the same thing. And now if you take a look, you might be thinking, hey, we could simplify this even more, because we've got x plus 1 to the first power in the numerator and x plus 1 to the 1/2 in the denominator. We could do that division, and all we have to do is subtract exponents, and we end up with x times x plus 1 to the 1/2 power dx. Okay, but now at this point things are looking a little bit messy, and so this is the time that we're going to use substitution. And we would like to substitute in place of maybe the most complex looking function here. And if you take a look at this, we have x plus 1 to the 1/2 power. It would be nice to just have, say, maybe u to the 1/2 power. That would certainly be a lot nicer than x plus 1 to the 1/2 power. So let's do that. Let's let u be equal to x plus 1. And so we're going to make some substitutions based on that. Okay, and so then what if I took the derivative on both sides of the equal sign? So I would have du equals 1 dx, or du equals dx. So I'll be able to substitute in place of dx. I can just put in du. But what about, we also have an x in there. Can I write x in terms of u? And you might be thinking, well, sure, you could go back up to that u equals x plus 1 and solve that thing for x, and we'll get x equals u minus 1. Okay, so now we have something that we can substitute in place of our x's. We'll have u's instead, and this could make for a simpler problem. Let's see if it does. So we're going to replace x with u minus 1. We're going to replace x plus 1 with u. And we're going to replace the dx with du. Okay, and let's go ahead and rewrite that one more time, where we actually have the u minus 1, and then that's being multiplied times u to the 1/2 power du. Now it might occur to you that we've got a multiplication there. We could distribute that u to the 1/2 power into u minus 1. And I think that's a good idea. Let's go ahead and do that. So u to the 1/2 power times u is u to the 3/2 power, and then minus, and u to the 1/2 power times 1 is just u to the 1/2 power, and then du. Okay, now we can take the integral of each of those terms. The integral of u to the 3/2 power, all we have to do is increase 3/2 by another 1 or 2/2, and we'll get u to the 5/2 power divided by 5/2, or that's the same thing as multiplied times 2/5. And then moving over to the second term, we'll increase u to the 1/2 power by 2/2. That'll give us u to the 3/2 power, and then divide by 3/2, which is the same thing as multiplying times 2/3. And we have a minus sign in there. And because we're talking about an indefinite integral, we need to remember to put plus c. And I think we're just about there. All we need to do now, we've integrated. It was a lot simpler to integrate after we replaced u, after we substituted in place of u. In place of x plus 1, we put u. And so now let's reverse the process and replace u with x plus 1. And so we'll have 2 times x plus 1 to the 5/2 over 5, subtract 2 times x plus 1 to the 3/2 power over 3 plus c. And we've completed this problem. That's it for this time. We'll see ya.